me recall it. All right, so for this problem, one way to think about it is um so this area and that area, we actually notice that if we draw extension line here and here, right, these two triangles are congruent to each other. And therefore the sum of these two would be just this square. And it's identical to that. And you can do this for the remaining area. So this part becomes here, right? So that's why these auxiliary lines are really helpful. And you end up having 4 extra of these, right? So it turns out, 5 of these x equals 15 times 15, right? So if the unknown area is x, so x is equal to 225 divided by 5, right? It's 45. Or you can say this, is 3 times 45. So it's 45. So this is a quicker way, but you could also do a slower way. A slower way would be, so like, let's say this little area we don't know, but let's say it's y. Um, and then you can figure out what's the relationship between this and the other shapes. Like for example, one useful conclusion in geometry is that if two triangles are similar to each other, then the area ratio is equal to, what's the relationship between the area ratio and the side length ratio? The same. So okay, so as an example, if we look at um where's the let me try to I'm trying to denote it in red. Hi Jackson. What is the area ratio of this triangle to the bigger triangle?
Would be
So if this little area is y, what is the big area?
big area. Not join now. One square. One square.
Well, so this little triangle is similar to the bigger triangle, right? Can you see that? They're
Yep.
similar to each other.
Yep.
Now, for similar triangles, and we know that the side length, if this is 1, then that is 2, right? Because this is the kind of the midpoint.
Yep.
So it's the midpoint. So its side length is 1 over 2. Now the area ratio is 1 over 2 as well?
4.
4, right? Because the area is, you know, is 1/2 base times height. Now, if you compare these two areas, so this base is 1/2 of that, and this height is 1/2 of that. So base times height, each is 1/2. So the ratio would be 1 over 4. So meaning if the small area is y, then the big area is 4y. So that's something I hope you can master by heart. So for two similar shapes, the area ratio is equal to the side length ratio squared. Okay. So that means this whole thing is 4y, 4y, 4y. And then what about this area? What about AHD? So AHD, isn't it just 4y plus y? So AHD, right? It's just 4y plus y. And that's 5y. Correct? So 5y equals what? We know AHD area is just 1/4 of the total area, right? Because AHD AH is 1/2 of AB, and the height is the side length. So AHD is the 1/4 of the total square. And by this way, we can solve for y. And then you can say, okay, now this shaded area, shaded area S is just equal to 15 times 15, which is 225, minus how many y? So we know each of these triangles is 4y. So, and we have 4 of them. So 4y times 4, right? And we already solved for y. So we can plug it in to calculate the area. So this is kind of the algebra way. So we set, one of them little area is y, and then we find the equation to solve for y. And then we also write, on the other hand, we write the unknown area as a function of y. Then we solve the problem algebraically. Okay. So this is if you do not think of the smart way to like draw the auxiliary lines, then you still use the algebra way to solve the problem. Okay. Because sometimes the smart way may not be as obvious. Okay, very good. All right, so let's move on to the next challenge. So how do we find the length of this? Should I start talking about it? Or are you guys still thinking about it? I can give you some hint to begin with. How about that? So how do we tackle a problem like this? It seems to pretty challenging, right? But in geometry, one of the quantitative, we often think of quantitative relationship. Now, one of the most useful quantitative in geometry is the Pythagorean theorem. Right? When you see, side lengths like this, you should think about the Pythagorean theorem because that's a quantitative relationship, right? Now, but how do we use it? Use Pythagorean theorem? Well, in Pythagorean theorem, we have to, use the known condition as either hypotenuse or legs, right? So this one looks more like hypotenuse. Right? How do we make a right triangle out of it? Well, if we draw, let's say this is let's say this is A, B, C, and D. Okay. Hey Jackson.
Yep.
Okay, we're working on this problem now.
Yeah.
So the way to think about it is how do we use Pythagorean theorem? Now, let's say this is O, and if we draw OE perpendicular to DA, isn't that a right triangle immediately?
Yep.
Right? So now we can use Pythagorean theorem. So let's say this is, A1 and this is A2, okay? And this is H1. So according to Pythagorean theorem, we have A1 squared plus H1 squared equals 4 squared, right? That's just Pythagorean. Now, in this triangle, we could also do Pythagorean theorem. So that would give us A2 squared plus H1 squared equals 6 squared, right?
Yep.
Now, what do we do with these? I mean, there are many variables. We have A1, A2, and H1. So in mathematics, we try to eliminate, um, yeah, we try to eliminate the unknowns as much as possible. Now, we found that they both have H1 squared. Now, if we do subtraction, that'll be natural, right? So basically, if you used second, and subtract the first from it, right? So what do we get? 2 minus 1. So we get A2 squared minus A1 squared equals 6 squared minus 4 squared, right? And that's very good. So that basically tells us, A2 squared minus A1 squared is equal to the square difference between these two hypotenuse. Now, can we do the same thing for here? Jackson.
The same thing here.
Yeah. how do you, like we did it here, right? For this triangle.
Yeah.
Now, what if we do the same thing here? What do you get?
Now, hold on. I don't really know how to use the Pythagorean theorem too well.
Okay.
B squared plus B squared equals C squared.
You know a squared plus b squared is equal, right? A right triangle. Now, what if we draw another line perpendicular to the top? And let's say this is F. Okay. So I want you to write down the Pythagorean theorem for this. I'm just very similar to what I did. And then you will find out. Trust me, you will find out. Justin, can you try to do that? Do you understand this part? That's,
Sorta, yeah.
do you understand this part? So we have a1 squared plus h1 squared equals 4 squared. That's in this shaded right triangle.
Yeah.
And then we do it for the other triangle here.
Yeah.
And that equals 6 squared. And now they both have h1 squared, so when we do the subtraction, h1 squared disappear. Right? That's we end up here. And now we're trying to do the same thing to the top. Hmm? Okay. And what do you get from there? Jackson,
What?
could you try to write down the equation?
I left my pens in the other room. I use my pen.
Okay.
Well, up there, since it's a straight linear line, this would be A2
Mm-hmm.
and A1.
So let's say this is x. So what we're trying to find is x.
And then A1 plus height.
Yeah, let's say this height is h2.
Equals x
Yeah.
and h2 squared plus h2 squared equals 5 squared. Down. So what next?
Yeah, so you can write down a1 squared plus h2 squared equals x squared. Right? That's from this triangle. And then a2 squared plus h2 squared equals 5 squared. Right? That's from the other triangle. Now, they both have h2, which we don't want because we don't know it. So we cancel out that. So basically we do another subtraction, right? So we get a2 squared minus a1 squared equals 5 squared minus x squared. Right? Now we have these two equations and we don't know a1, a2. But that's okay. Luckily, the left-hand side are the same. So we end up having a new equation that involves only one unknown, which is x. So 5 squared minus x squared equals 6 squared minus 4 squared. So now you tell me what is x squared. Yeah. So x is just square root of 5. Not like some of you might have guessed it's 3, 4, 5, 6. I guess some people might think, but if it is a multiple choice, three would be one of the deceiving options, right?
This is of AMC 8 or 10.
Well, I think the level of thinking is AMC 10, yeah. Um, okay. Are you good?
Yeah.
Let's move on to the next one. Okay. Any question from online people? Right. Let's do a couple more. So we have a semicircle that has a diameter AB and chord CD of length 16 parallel to AB. A similar semicircle with diameter on AB and tangential to CD is cut around the large semicircle as well. What is the area of the resulting figure shown shaded? Jackson, you look at this point.
Yeah, no.
Mm-hmm.
It's
Mm.
mhm, mhm, mhm. The first one. She had a. Why don't we get A B?
Yeah, we don't know AB, but we know CD.
Yeah, here, wow, we don't.
Hmm.
I think it would be E actually for this one.
Hmm?
Would it be E for this one?
Why?
Why?
Gut feeling.
Well, you also need to be able to solve it without choices. Let's say that if there's no
right.
choice. Huh?
So that means I'm right.
Uh-huh. Yeah. How do you solve it rigorously?
Mhm.
Yeah. Oh, okay. Oh, you took the okay. Did you solve it?
What's the answer? No, no, this one I didn't like. I didn't know how to do.
Oh,
This one was fine.
Yeah, I can-
just went off of
I
gut
can
feeling.
show you how to do it in 20 seconds.
Nah, I just felt like that it would be like 18 for 8B, a rough estimate. So it'd be like
Mhm.
the full circle would be the semicircle here would be pi 40
Okay.
and a half.
So yeah, shall we go through it together in the interest of time? So this one, okay, so first you want to write down the formula for the unknown, right? For the shaded area, we know that it's the half of the circle.
Is it B?
No. It's half of the big circle, right? So 1/2 pi
Really?
r square, right? And minus 1/2
Yeah.
pi little r square, right? This is little r. So it's basically pi over 2 times r squared minus r squared, right? And this is also already very good because we know this is R
Wouldn't that be 0?
and this is R. And this looks like very much like A squared minus B squared or C squared minus B squared, right?
A squared.
So that equals A squared. That gives us some hint. So how do we find the A squared? If you connect, so let's say this is O, you connect this with D, right? And you draw a perpendicular line here. Now, because this is perpendicular, so this height is just R. You see that? And this hypotenuse is R, is capital R. And what is this? This is just 1/2 of 16. So this is 8. So we have R squared minus R squared equals A squared. Pythagorean theorem. Inside this triangle. So now you just need to plug 64 inside and get 32 pi. 20 seconds.
Got it.
So C.
It was C.
Yeah. So, I mean, this is a good example of how, like, you can start from, what is the unknown? And then you can make the observations there. That sometimes will give you a hint. And oftentimes, this is Pythagorean theorem is very helpful for this type of geometry problem. Okay. Yeah. And we're running a little out of time, but if you want to hang out a little longer, we can do one more. So this is basically it's also from the last fall, it's number 13. So we have an outer square that contains infinitely many squares. Each of them have the same ratio, the side length ratio is the same, is K, okay? And as it's alternating, and now the area of the shaded portion of the figure is 64% of the area of the original square. What is K? Right. And I can also show you how to do this in 20 seconds.
You can do it in 37.
Yeah.
So it's D, but
How do you do it?
So
There,
I don't know how to explain this well.
Okay.
is that-
You can do it in about 30 seconds. There's some stupid, simple thing you can
Yeah.
do that's just kind of toxic. Real. Bro, I can't tell if you're looking for the top of a pyramid or looking into a hole.
Oh.
looking into a hole.
But
I'm
if you
looking into
like,
a tunnel.
if you
Yeah.
zoom back,
Yeah, we're
you
kind of
can-
looking through a tunnel. Yeah.
You can kind of imagine it jumping out at you if you like lean back and taking the whole picture,
Yeah.
right?
Mhm.
Is that true of anyone else?
Did you do this one?
My brain is.
I'm pretty sure I know this one, but
I don't remember the
guess.
Okay.
I'm just gonna take a random guess at B.
D.
B.
It's D.
It's B.
D.
It's B.
It's 100%.
It's literally B.
They would not make the area of the shaded portion.
I wonder if
the
someone would
answer.
take a ruler and just measure it.
No, I want to do that. Actually,
That's not a bad idea.
actually, it says that it doesn't say that's not John's scale. It's
You can
like, give me
actually use a ruler.
Give me a ruler.
No, because are rulers allowed?
I think rulers are allowed.
Wait, what?
Easy.
Yeah.
That's
So people would just bring a really like fine ruler. Oh. But anyways, so shall we go through this together quickly? Okay, so first of all, it says the shaded area. We know that they are. So we have this relationship, right? If the two shapes are similar, then the area ratio is equal to the side length ratio
Where?
squared. Yeah. So that's good to know. And we also know that because it's so if you think of this one and that one and those all those shaded inside, right? Their ratio is also, I mean, it's basically a geometric sequence, right?
Yeah.
And for geometric sequence, we know the total area, sum of this shaded area is just the big area. So let's say um this big area is this is one, okay? This side length is one. So it's one times one over um one minus, let's say this is the ratio. Um the ratio in this case is actually because the adjacent one is k, so it's k squared. Okay. So it's basically one over this. That's for the infinite geometric sequence. But this doesn't matter. I mean, it's actually the same. So because what really matters is if you look at the difference between the shaded and the white one. The white one would be this area, which is k squared. So the white one is starting from the biggest one is k squared because the ratio is k, right? So we know that the area ratio is the square of the side length ratio. And then times the same factor, 1 minus k squared. So even if you don't know this part, you know that they're the same. That's what really matters. Because at the end of the day, we want to know what's the ratio between the white area versus the shaded area. Okay? Because we know the shaded area is 64% and the white area is 1 minus that. So it's 36%. Right? That's the white area. So white area versus the shaded area is this. That's the area ratio. And we know that area ratio is the square of the side length ratio. So that is equal to side length ratio is k, so k squared. So all you need to do is to calculate this. So k is just equals to square root of that. So it's just square root of 6 over 8. So that's 3 over 4.
No, bro, it was the.
So you're right.
Was
Yeah.
That's insane.
But
I was right.
but
That's insane.
but I hope I convince you, if you know this is the essence, then it's truly a 20-second practice. Right? All I do is k squared equals 36 over 64. And k equals 3 over 4. Okay. Any questions from online people? I hope this has been helpful. We didn't have time to get to the more difficult problems, but next time we will. And I think it's good for you to be exposed to some challenging problems. That's how the brain works. Is that you challenge itself, and then you got stuck, and then once you understand the solutions, that helps you, opens up new, brain activities, right? Synaptic activities. So you now this uh path works. And that's how you progress in mathematical thinking. And then we'll also try to like expose you to multiple ways to solve the same problem, and that would be very enlightening as well. So you can think of the same problem from different angles. And for some problems, you have 3, 4 different ways to solve it, and I think that would be really helpful for you. So we'll start from geometry, and then we'll progress to counting probability, number theory, and algebra and other topics. Yeah, and again, I also welcome any feedback, any suggestions or areas that you would like me to cover more. And we can always adjust them according to your needs. Okay. And if your parents are interested in signing up, please let them contact me after this. All right. Again, thank you for your attention. Apologize for the initial technical difficulties. Um, but all worked out. All right. And you're also welcome to bring your problems. Like if you have some problems you got stuck with, you want me to explain it, especially like to explain how to tackle these problems. I think some problems you could maybe get solutions, but just by looking at solutions doesn't sometimes doesn't help you, right? So I can help you to like getting the bottom of how to tackle these problems, how to think about solving these problems. I think that would be really helpful to progress in your mathematical creative problem solving. Okay. All right. Thank you all for your attention. I hope to see you again. Bye for now.
你好，
哦，你好。嗯。
我想问一下，就是你们这个讲座什么时候有？就是你可以，就是我怎么样能得到？就是说你可以 inform 我吗？
哦，您可以加我微信吗？就是我们
我好像，
有个微信群。
哦，行，
嗯，就是我可以，您在我这个群里头吗？
我不在你的群，但是我好像是有你个人微信。
啊，对，您是哪一位？
你搜一下，我叫郝志芳，
哦哦，好像看到过
你
您。
搜到了吗？
对对，哦，看到了。
你可以把我拉到群里吗？
哦，可以可以。
谢谢。
您孩子现在是，他刚才听了吗？
他听了一部分，然后他就有事走了。
哦，OK OK，他现在是什么水平？
他6年级，
哦，OK，他就是 AMC